Hey everyone, Jen Person here. Ever wonder how Cloud Functions can keep your mobile app from getting bogged down with resource-intensive CPU or networking tasks? Let's find out on today's Firecast. Let's say I have a photo app. Users upload photos which populate a grid of thumbnail images. Users can select a thumbnail to see a full-size version of the image. While creating a thumbnail could be done from the client, it requires extra processing and an additional upload to cloud storage with each image. One of the original image and one of the thumbnail. My users love my app, so they upload lots of pictures. I want to make sure I give them the best experience by offloading the work using Cloud Functions. With Cloud Functions, I can eliminate the additional work from the client. Even better, if my app is on more than one platform, I don't have to code the same process for each app. The code I'm going to show you today is similar to one of the function samples in the GitHub repository, so feel free to follow along using the link in the description below. Today, I'm going to use 3 additional tools. First, I'll use a software package called ImageMagick to create a thumbnail. This is already provided by Cloud Functions as a command line program, and you can read more about it in the description below. Next, I'll use a module called Child Process Promise. It lets me run the ImageMagick CLI. And finally, I'll use the Google Cloud Storage module to upload the thumbnail to my storage bucket. Let's get these set up. I'll go to the functions directory of my project and use npm to install the Google Cloud Storage module. You can see I use save in my command. This adds the package name as a dependency in the project's package.json file. Cloud Functions will only install the modules declared in your project's package.json file when you run the Firebase deploy command. So now when I install the Child Process Promise module, I'll use save again. I'll open package.json, and you can see that the Google Cloud Storage and Child Process Promise modules are listed. Now that the environment is set up, let's dive deeper into how cloud storage triggers work so we can implement the function that will convert uploaded images. Similar to the way I use functions.database to receive write events when the database changes, I can use functions.storage to receive events when files are changed in my storage bucket. The function I'll write today receives an event object that contains a property called data, which has the type object metadata. There are many properties of object metadata. For our purposes, we will use bucket, name, content type, and resource state. Bucket is the storage bucket for the object. In our case, it's a storage bucket associated with the Firebase project. Name is its path in storage. Content type is the object type. Storage can contain many different types of objects, so we will check content type to find out the type of this file. Resource state can have one of 2 possible string values, exists or not exists. We will use this property to see if the image has been deleted or removed. If the image no longer exists in storage, there's no need to create a thumbnail. So I'll use the bucket property along with the name property to locate and download the image from storage, then invoke ImageMagick to create the thumbnail, then upload the thumbnail to a new path in cloud storage. I'll show you what that looks like now. You always start with the Firebase Functions module. I'll add the require statement for the Google Cloud Storage module. The Cloud Storage require is passed with parameters used to configure storage. Since Cloud Functions is part of the Cloud Platform, and all Cloud SDKs auto-initialize inside the Cloud Platform, I don't have to worry about config. I'll also add the Child Process Promise module. This module provides 4 different methods for executing external programs. The method I'm going to use is spawn. The spawn method loads and executes an external application in a new process. I'm going to define and export a function called generateThumbnail. This will trigger whenever a file changes in my storage bucket. The function receives an event that describes the object that changed. I'll get a hold of the object metadata property from the past event. This contains all the information about the file that changed. I'll store the object's name in file path. I can then get the object's file name from the path. The JavaScript method split converts a string into an array. The parameter passed into the function determines where the split occurs. Pop removes and returns the last element in an array. I'll define a constant for the bucket where the storage change occurred, and I'll create a reference to the file bucket using the Cloud Storage API included earlier. Then I'll make a string with a temporary file stored locally on the Cloud Functions instance. This will hold the image while it is being modified. I have to handle a couple scenarios that can occur. I'll need to check if changes to the storage bucket are images before I try to resize them. Also, there's a chance that the image could disappear from the storage bucket as the function begins to execute. Say, if a user uploads a different picture than what they wanted, so they take it down right away. I'll want to check if that image still exists, or I won't have an image to download. I'll get the content type of the newly added object using the content type property I mentioned earlier. If the content type does not start with image, there's no need to continue executing the function. I'll log the event and then return. To see if the object still exists, I'll check the resource state property. If the value is the string not exists, then the object has been deleted, so I'll return out of the function after logging the event. Now here's where the magic starts to happen. If you watched the last video, recall that we chained together several then method calls to trigger each method after the previous promise was returned. This ensured the function didn't try to read data that wasn't yet available. And since we need to download the image, then resize it, then write the resized image to a new path in storage, this is the perfect time to chain promises to make sure the work happens in the correct order. My first bit of work will be a download of the storage object that has changed. I'll download the object to the temporary file I just created. The next bit of work I want to execute after the image is downloaded is the actual resize of the image. I will then use image magic to convert the image to a smaller size. In this case, I'll choose 200 by 200, which looks like this. Spawn executes the image magic convert CLI and then returns a promise that will become resolved when the conversion completes. This final bit of work uploads the thumbnail. First, I'll designate a file path where I'll upload the image. I'll want to store the thumbnail in a different location than the original, so I'll prefix thumb to the name of the original image. This helps clarify which thumbnail is for the image, and also serves as a way to prevent infinite loops. I'll talk more about that later. If you aren't familiar with the crazy series of symbols in the replace function, this is a regular expression, or regex for short. It uses a special text string to describe a search pattern. This particular regex matches to the end of a string that contains a slash, followed by a 0 or more of any character that is not a slash. Find out more about regular expressions in the links below. Now I'll upload the image to the newly created path in storage. I'll also add logs so we can check things out in the Firebase console. I have an important loose end to tie up before deploying the function. When I add a thumbnail image to storage, I've changed the contents of the storage bucket. That means the function will be triggered again, and again, and again. I definitely don't want an infinite loop to occur. When I wrote a database trigger in an earlier Firecast, I used a Boolean flag to check if the function had already been executed on a post. For the storage trigger, I'm going to use the name of the storage object to determine if the image is a thumbnail. I'll address this in our code now. Earlier, I mentioned that adding thumb to the name of the image after resizing would be used to prevent infinite loops. Here's where that comes into play. I check if the file name starts with thumb, and if it does, I log the event and return out of the function. Now in the terminal, I'll run Firebase deploy to deploy the generate thumbnails function. I'll head on over to the Firebase console and select storage. I'll upload an image, and I can see the image added to storage. In order to see the thumbnail, I'll refresh the page. And you can see the thumbnail has been created. Sweet! In the function's logs in the console, I can see when the image was downloaded to the temporary path and then resized. I can also see a log that an object added to storage is already a thumbnail. This shows that the function was triggered when the thumbnail was added to storage, but there was no need to generate a thumbnail, so the function was exited. Breaking it down, generate thumbnail downloads the image, then resizes it, then writes the resized image to a new path in storage. And, as usual, remember to return your promise or you can end up with a cryptic error message instead of a thumbnail. So now you see how Cloud Functions can be used to offload data and memory-intensive tasks away from the client. But wait, there's more I can do with my cloud storage trigger, so tune in to the next Firecast for part 2 of writing a cloud storage trigger. If you are ready to write some Cloud Functions after watching this video, make sure to hit like. Also, subscribe to the Firebase channel on YouTube to get notified when new Firecasts are released, including part 2 of Cloud Storage Triggers. Thanks for watching, and I'll see you here next time.